Okay, now discussing a plot that is very much related to the correlation matrix. I often run these two in a fairly similar plot in my data now, or close together in my data analysis. And just so the thing to realize about a pair plot is it's so busy. There's really too much. It's never usually your final presentation, the plot that you're going to share in your presentation or with your colleagues. It's to help you to figure out what to analyze next. There's so much going on. We get so many sides, so many different views of our data set, and really we can then determine using our human eyes, which are really good at detecting patterns, and really see what makes sense to explore, more in depth and to go a little bit further. Where, because by very, when you think about that, you're getting that's a lot of relationships that you have in your data set, right? It's exponential. And so it makes a lot more sense to kind of narrow those down and then focus on a few of these relationships that, show a good relationship, show kind of a funky pattern, kind of like this one right here. This looks like it could be almost a sort of correlation, or what's going on here? Why is there a little bit data floating off to this side here? Or this looks like a tighter correlation. Not so much though, but it'd be interesting to understand what density is supporting this correlation right here. Okay, so it kind of goes hand in hand with the correlation matrix that we saw in the Seaborn heat map. Okay, and so this is kind of cool. We can control the diagonal as just the univariate analysis. So when this column one by column one, it would just be the univariate analysis like this, and the rest would automatically plot the bivariate relationships of each feature. So column one with column two, column one with column three, and so on and so on and so on. Okay, and so it really allows you to see so much so quickly, and then from there go a little bit more in depth on the ones that seem interesting. Another really interesting version of this is the Pairgrid that gives us access to a little bit more flexibility in how we build this. And I think one of my favorite ways to use this is doing a regression plot on one side. So same thing that we just saw the scatter plot, doing now a regression line on each axis, kind of giving a sense. We're also doing a swarm plot down in a diagonal, which just gives a lot of detail on where the data actually is. And then looking at this, we can see downward and positive trends. But it's really interesting to see the mirror image of the opposite side of this regression analysis and really focusing on where the errors are happening. Understanding if there's multicollinearity, heteroscedasticity can be really interesting to understand these errors. They should be random, but if we start to notice patterns between the regression errors and the regression, it kind of, lets you say maybe there's ways that we can improve this model. Okay, maybe there's something more interesting going on with this relationship where you see we're missing a lot of the really large values. We almost kind of fan out a little bit. And then we also a lot more orange here on the upper end of this regression. So it'd be interesting to understand why that's happening. Right? Why are we making more errors apparently on the upper end of this regression? Yeah, so it's just really helpful to see kind of the mirror image, not the exact same side, but a mirror image, the other side of this regression.